Here we have some problems that involve similar triangles. And the thing to remember about similar triangles, you can tell they're similar if all their angles are the same. So one triangle might be big, one triangle might be small, but if they have all the same angles, then the sides are going to be proportional. They're similar triangles, the sides are proportional, the angles are all the same. Take a look at this figure right here. This is a pretty common thing to see in math problems, where they take a triangle and they kind of slice it down the middle with a line that meets the bottom here at the exact same angle that you have over here. What you get is two triangles there. The big one that encloses the other one, and this little one here. Now, they share one angle. They share this angle B down here. This angle is 120. This angle of the big triangle is 120. And if that's the case, they've got this angle in common and these two are 120. These angles, x and y, must be the same as well. So these triangles are proportional or similar. Let's take a look at what the question is asking. It says, which statement is true for the diagram? A, x equals 60. Well, if x was 60 here, we'd have 60 plus 120. That would be 180 degrees already in a triangle for only two angles. That wouldn't leave anything left over for angle B. So that's not going to be it. B says A and B are supplementary, so this angle and this angle. Well, supplementary means adds up to 180. Again, you'd have two angles in a triangle adding up to 180. Not going to happen. C says x equals y, and as I was explaining about these similar triangles, I mentioned that x and y do have to equal each other because B equals B, this angle is shared, these two angles are the same, so the third angle in the triangle must also be the same. So that's going to be our correct answer there. Let's take a look at this next one. It says in the figure shown, segment PQ is 24, ST is 8, and normally I'd start jotting these in here, except you'll see in this problem that we don't need that information. It's extraneous. And then it says measure of angle QRP, that's this one right here, is 74. And they want us to find the measure of angle S down here. Since we're doing problems about similar triangles, you might think maybe these triangles are similar. Well, you can show that they are. You'll notice here we have a right angle and here we have a right angle. So in both these triangles we've got a 90-degree angle. And then right here, these two angles, they are vertical angles. So whenever you have two lines that cross like that, the angles that are across from each other are the same. So in this case, this angle is going to be 74 as well. And if you've got a 90 and a 74, well, what's left over is going to be 180 minus 90 minus 74, and I think that's 16. So the measure of angle S is 16. Measure of angle P over here would be 16 as well. And because they have all the same angles, you know they're similar triangles. So since you're given the sides here, you could figure out the other sides because the triangles are proportional. Let's move on. All right, we've got one more here. This one says one triangle is shown on the grid, so this guy right here. Two coordinates for a second triangle are also shown on the grid. Which of the following sets of coordinates will create another triangle that is similar to the triangle that is shown? So when triangles are similar, they have sides that are proportional. So probably what I'd want to do is count the lengths, figure out the lengths of these sides, although I'll ignore the hypotenuse because that's a little harder to figure out. With these other two sides, I can just count. We've got 1, 2, 3, 4 units here, and we've got 1, 2, 3, 4, 5, 6 units here. So if I wanted to get a triangle that was similar to that, the sides would be in proportion. There might be a triangle that had one side 2 and the other side 3, or one that had one side 8 and another side 12. Let's see what we get here. These two are 1, 2, 3 apart. Now, these are our choices for extra points to put in there. The 0.62 would be 1, 2, 3, 4, 5, 6, sorry, 6 and negative 2 would be right there. And I'm not even going to try to measure the lengths of the sides there. This is clearly not going to be a proportional triangle. It's got to look like this, at least in its angles, and that certainly doesn't. So that one's out of there. B, negative 6, negative 7. 1, 2, 3, 4, 5, 6, and 1, 2, 3, 4, 5, 6, 7. So that looks like maybe a promising possibility. But let's count the points. We've got 1, 2, 3, 4. So this will be a triangle with one side of 4 and one side of 3. And if we set up a proportion here, so short side, long side equals short side, long side, what you see is these don't really work. This is 2/3 and that does not equal 3/4. So that point doesn't work either. Let's try the next one, -6, -5. That's going to be right here. So we'd have this triangle. And that's got a side of 3 and a side of 2. And then if I do the same thing, short side over long side from my original triangle and short side over long side from my new triangle, what I get is something that's equivalent, that's equal. So 4/6 is 2/3. So these triangles are have proportional sides. That means they are similar. So C is our answer. So that's a little bit of work with some similar triangles.